Okay, Unit 7.
Dance tickets are available during lunch hour. Today and Monday will be the last time to buy your dance tickets during lunch hour.
Is called series and sequences, and we're going to talk about the basics of them. Okay, so you have two types of sequences: arithmetic and geometric. Okay, those are the two types. So I'll give you an example of an arithmetic one. We're going to go 3, 7, 11, 15, etc. So this is an arithmetic pattern. So describe to me what's going on from here to here, here to here, here to here. Should be the same thing. Okay, so if you can see it, every single time to go up, you're adding 4. Okay, so what we're going to call this 4 is that it's the difference. So the D is equal to 4. Okay, so if you can't see what the difference is, just visually, what you can do is take a term and subtract it from the previous one. So if I say like term 2 subtract term 1. Okay, you can pick any term, so term 5 subtract term 4, whatever you have, if you subtract a previous term. Okay, let's try another one. Negative 11, negative 17, negative 23, negative 29. What's going on in that? Okay, so this time, let's just not do the visual way, I'll just do the algebraic way and see what's happening. So I'm going to take a term, let's pick this one. I'm going to subtract its previous term. Okay, subtracting a negative makes me add. Negative 29 plus 23 is negative 6. So every single time in the sequence, as you move on, you're going down by 6. So our difference is negative 6. Okay, so geometric, how is that different? This is what a geometric term could look like. Okay, so in this sequence, what's going on every time? Can you see it? Every time you're timesing the previous term by 2. So this time, we don't have a difference, we have what we call a ratio. Sorry, I should have written a difference over here. So a D and a ratio. So this would be our ratio is 2. So how do you figure this one out? You take a term and divide it by its previous term. Okay, so you can see that I would subtract a previous, here I divide a previous. So let's look at another one. 5, negative 15, 45, negative 135. What's going on? So I'm going to take a term and divide it by its previous. So negative 15 divided by 5 equals negative 3. So my R is a negative 3 every time I'm timesing the term by negative 3. Okay, let's look at another one here. 180, 60, 20, etc. What is the R? Okay, so I get this problem a lot that people see a visual of, oh, I know that's 3 times the amount, so my R is 3. Okay, but that doesn't make sense because if your R was 3, you'd be getting bigger. Okay, so if we're going to get smaller in our numbers, our R must be like a decimal or a fraction number. So if I do a 60 divided by its previous, okay, that is 1/3. So in your head, I know a lot of you thought about that 3, but this is where it comes into play. It's 1/3 is your ratio. Okay, that's the one that tricks a lot of people, making sure that they know when their R is a fractional number. Okay, that is it for the basics.